Good afternoon. So today the class 3, third class, just recap for the last classes. Last class we can do for logical equivalences. So logical equivalences, some of the formula we can using is a De Morgan photo. I can put it for here. As a De Morgan was born in Madurai only. After 7 years old, he go to England. Okay. The name of the law, mostly we can using what are the laws for last class we can study it. So idempotent law, if both input are same, either conjunction or disjunction, the output is same. I think you can using the 3-line equal, logical equivalence, or simply you can write biconditional symbol also you can use. So identity law. So one of the terms should be true or false. P disjunction false will come, P will come, P conjunction true will come, P will come. Dominance law, if true will be occupied, the same one, P disjunction true, the answer is true. P conjunction false is false. Complement law or another name is a negation law, sometimes we can using commutative law, and then associative law, distributive law, absorption law. Absorption look like a distributive law, but the two inputs are same here, P and P, but distributive PQ are 3 inputs here, P, P and Q. So absorption law. De Morgan's law, that is a negation of P disjunction Q equal to negation P conjunction negation Q. Negation of P conjunction Q equal to negation P disjunction negation Q. That is a duality principle, like that. Conjunction will be changed to disjunction. That is a P converted into negation P. These are duality law language. These are the equivalences, logical equivalences by using disjunction and conjunction. Here the same formula, logical equivalences for conditional statement. P tends to Q or P conditional Q. So negation P, disjunction Q. That is the name of the formula, conditional as disjunction. Most of the problem we can use this formula. P tends to Q equal to negation P, disjunction Q, logically equivalent. And P tends to Q, negation Q tends to negation P is a contrapositive. Normally we can say that P disjunction Q, we can write negation P tends to Q. P conjunction Q, negation of P tends to negation Q. These are the things, rare cases we can using. The first two or third one we can remember. Only first one it's enough. Mostly we can using the first term and the third one. And also the last one. P tends, last 3 things. P tends to all. Last one already I told to you. P tends to all, conjunction Q tends to all. If you can take all, tends to all, take common outside, the conjunction symbol. Right side, if you can take in common outside, the conjunction symbol change to disjunction symbol. Left side, you can take common outside. It is nothing but say same symbol. Disjunction will come. That you have to remember. Right side only, if you can take common, the value should be the conjunction will be same. Okay. And then this is for biconditional symbol. Logically equivalences using biconditional. P biconditional Q equal to P to Q and Q to P. P biconditional Q negation P biconditional negation Q. That is also sometimes we can using. And this is also we can using functionally complete set of connectives. Upcoming topic we can use this formula. P biconditional Q can be written as P conjunction Q disjunction negation P conjunction negation Q. Yeah. And next, duality principle, duality law we can study. The dual of a compound proposition that contains only the logical operator disjunction, conjunction and negation is the proposition obtained by replacing each disjunction by conjunction, conjunction by disjunction, true by false, false by true. That is a negation. True by false, false by true meaning is a negation. Or special variable representing compound proposition that are tautologies and contradiction respectively. So the dual of the proposition A is denoted by A star. Now in the dual symbol we can use A star. So now we can easily verify that A implies B and B implies A. Then A equal to B, A equivalent to B. Hence, to prove the equivalence of two proposition, it is enough to prove that each implies the other one. And a tautological implication. Numerically, we can first one you can study the previous one. Yeah, anybody got that? Those who unmute, ma, please mute. If you have any doubt, I can clarify. Okay. Yeah. And tautological implication, that is a P implies P disjunction Q meaning. How to prove for this one? P conditional embedded in bracket P disjunction Q is tautology. We need to show the logical equivalences, meaning both the output, left hand side or right hand side, right hand side, you have the same truth table values. Here we can use P tends to P disjunction Q is a tautology. We can prove like that. This up to this we can study it in the last class. Now we are going to functionally complete set of connectives. Next we can go for functionally complete set of connectives. A set of connectives is said to be functionally complete set of connectives if every formula can be expressed in terms of an equivalent formula containing the connectives only from this set. So what set you are giving? For example, the set of connectives conjunction and negation and disjunction or negation are functionally complete, because we have studied till now conjunction, disjunction, conditional, biconditional, exclusive or, NAND, NOR. So all the things except conjunction and negation, we can try to convert all disjunction, conditional, biconditional can be expressed in terms of conjunction and negation only. Any formula, P disjunction Q and P conditional Q, P biconditional Q, P NAND Q, P NOR Q, like etc. Whatever that things, everything should be can be written in the connectives only conjunction and negation. Then the set of conjunction comma negation is called the functionally complete set of connectives. Similarly, disjunction, negation are functionally complete set of connectives. Individually, negation, separately, conjunction, disjunction, or without negation, we cannot express conjunction and disjunction. All the formula we cannot express in terms of conjunction and disjunction, we cannot express, including negation will come, are not functionally complete set of connectives. That is not complete. So from the above 5 connectives, conjunction, disjunction, negation, conditional, biconditional, we have obtained at least 2 sets of functionally complete connectives. Prove that negation, disjunction is a functionally complete set of connectives. So most important, either 2 mark, there are cases for subdivisionally they can ask in 4 mark. So to prove negation or disjunction is a functionally complete set of connectives. So all the other connectives, conjunction, conditional, biconditional, can be expressed as in terms of only negation and disjunction. You can convert the equivalent formula negation and disjunction. Okay. Now we can solve P conjunction Q. This can be written as, first you can use the De Morgan's law, negation of, first you can use the double negation law, negation of negation P, then you can apply the De Morgan's law. First you can apply the formula for double negation, negation of P conjunction Q, first step you can write. Next step, the negation bring inside, outside negation is as it is, the inside negation bring inside negation P, the conjunction converted into disjunction, negation Q. That is a De Morgan's law. So now converted conjunction converted into disjunction and negation. P tends to Q. That's the formula negation P disjunction Q. P biconditional Q. We know the formula P to Q and Q to P. Then the next step, P to Q can be written as negation P disjunction Q. Conjunction, negation Q, disjunction P. Again, we have to change this conjunction. How to change the conjunction? Already we can prove the first one. If P conjunction Q, then we can write negation of the first input, disjunction, negation of the second input. So this is my first input. This is my second input. That's why I can write negation of the first input. The conjunction change to disjunction, negation of the second input using the first step. Hence, negation and disjunction is functionally complete set of connectors. Similarly, all the other 2 also you can do, NAND and NOR. That is also if you want to prove. Otherwise, you can. It is enough to prove these 3 things. That is for your 2 marks, most important 2 marks. Similarly, the same one. Similarly, negation and conjunction also we can prove the same method. Negation and conjunction. Only the changes for this symbol will be disjunction, and the right hand side everything should be the negation and conjunction. And prove that NOR and NAND and NOR. Upward is NAND, downward is NOR, are functionally complete set of connectives. They are also known as minimal functionally complete set, because previous one you know that there are two things is that negation and disjunction or negation and conjunction, but here only one term, only one connectives, NAND or NOR. That's why you can say is a minimal functionally complete set. Single step, single ida vachu you can use. Previous one we cannot express, conjunction vachu we cannot use, and disjunction only we cannot express, negation only we cannot express, but NAND and NOR we can express. Okay, in order to prove, it is sufficient to show that the set of connectives, conjunction, negation and disjunction, negation can be expressed either in terms of NAND alone or in terms of NOR alone. So both simultaneously I can prove both sides. So first negation P. I like to go for negation P. Negation P can be written as idempotent law. Negation P, disjunction, negation P. The first step I can using for idempotent law. Next I will apply for De Morgan's law. Negation of P conjunction Q. What do you mean by NAND? NAND. And that is a conjunction, not and. That is a NAND. Not and. That is a NAND. So not negation and conjunction. That is a NAND. We can write P NAND P. P upward arrow P. So now the negation P can be expressed as P NAND P. Similarly, I can go for NOR. What do you mean by NOR? Not all. Not all. That is a not all disjunction. First again I can using the same idempotent law, then I can apply the De Morgan's law, then I can go for P disjunction, P NOR P. Similarly, other two we can prove and disjunction, and P conjunction Q. P conjunction Q can be expressed as first same double negation law I can apply. Negation of P conjunction Q. Negation of P conjunction Q is nothing but P NAND Q. What is the previous one? What do you mean by negation P? Negation P can be expressed as P NAND P. Negation P can be expressed as P NAND P. Similarly, negation of P NAND Q can be expressed as P NAND Q, NAND P NAND Q. Same by first step. So P NAND, the entire term you can take it as P. So negation P can be expressed as P NAND P. Similarly, for here the same procedure you can write the RHS. One time they can asking for 8 marks. The same problem they are asking university question as 8 marks. So P conjunction Q can be negation of double negation and then De Morgan. Then try to go for the previous one. Negation P can be expressed as P NOR P. P NOR P. Using the negation P can be expressed as P NOR P. Okay. And the third one, P disjunction Q. Negation of negation P disjunction Q. That can be written as a double negation law. Then I can apply for negation law. So De Morgan's law I can apply it. And NAND, negation P, NAND negation Q. Again I can apply the same formula. Negation P can be written as P NAND P. Negation Q can be written as Q NAND Q. Similarly, here negation of P disjunction Q, P NOR Q. Negation P can be written as P NOR Q, NOR P NOR Q. That is a by one. That's all. No need to write for conditional, biconditional. In a condition, why I didn't write for conditional or biconditional? Already we can prove for conditional and biconditional can be expressed as the conjunction and negation or disjunction and negation, because conjunction and negation and disjunction and negation are functionally complete set of connectives. That's why we can write like that way. So write the equivalent formula for P conjunction Q to P. Try in your home itself. P conjunction Q to or disjunction or biconditional P. Q biconditional or this is also. Can try in your home which does not contain the biconditional. We want to remove the biconditional symbol from this. I think this symbol is biconditional. I think here I can run the mistakes. P conjunction Q biconditional or. So you know the formula Q biconditional or is Q2R and R2P. Similarly R2P and P2R. Just one step answer. Direct answers will come. Next, very most important topic, normal forms. We can expected 1 8 mark in the comes from PDNF, PCNF, principal disjunctive normal form, principal conjunctive normal form. So that's why I can using for here normal forms. What is a normal form? So the construction of truth tables, may not be practical. And every time we cannot write construction of truth table is not practically we can write, even aid of your computers. So that's why we therefore consider the procedures known as reduction to normal form, try to convert it into normal form. That is called a normal form. If we write the given statement formula in a particular form in terms of conjunction, disjunction, and negation, that is a functionally complete set of connectives meaning, then it is called normal forms. Hence, given statement formula and its normal form are equivalent. That is a logically equivalent. Before you can go for elementary product and elementary sum. Here product indicating conjunction, sum indicating for disjunction. So a product of a variable and their negations in a formula is called an elementary product. A product of the variable and their negations. That is the meaning. We can write the truth table as TT. For example, PQ, I can take it as the truth table. The P column, we can write true, true, false, false. In the Q column, I can write true, false, true, false. So, here the elementary product, the product of the variables, their negation and variables and the negations in a formula is called an elementary product. That is a P, negation P, conjunction Q, negation P, conjunction P, P conjunction negation P. Elementary sum, a sum of the variables and their negations in a formula is an elementary sum or disjunction. So P, negation P, disjunction Q. The numerator first one is the product meaning conjunction, sum meaning disjunction. And disjunctive normal form, a formula which is equivalent to a given formula and which consists of a sum of elementary products is called a disjunctive normal form. A given formula may not have a unique DNF. Some of the students can write a different way also. A formula which is equivalent to a given formula and which consists of a sum of elementary products. Sum meaning disjunction, product meaning conjunction. So inside the bracket conjunction will there, outside the bracket disjunction is there. So it is a sum of elementary product. D for disjunction, normal form. D na disjunction. Outside is disjunction, inside is conjunction. Conjunctive normal form. Outside is conjunction, inside is disjunction. That is a product of elementary sum normally we can write. That is a DNF, CNF. First you can go for some example of DNF and CNF. Then the main concept is PDNF and PCNF. Principal disjunctive normal form, principal conjunctive normal form. Right. What is the procedure to obtain the DNF or CNF of a given formula? What is the first step? If the connectives conditional and biconditional are present in the given formula, try to replace. Already we can study conjunction, disjunction and negations are functionally complete set of connectives. That's why conditional and biconditional can be expressed in terms of conjunction, disjunction and negation. That's why it is possible. That's why the first step, try to convert either conjunction. For example, by P conditional Q if is there, you can write negation P, disjunction Q. That's why here is a personal. Negation P, disjunction Q we can write. Suppose P biconditional Q will come, we can write P conjunction Q, disjunction, negation P, conjunction, negation Q. Or this, when you can use this in between bracket, middle term is disjunction. Upper formula of the DNF. Either D, either NF. That is a disjunctive normal form. Here, conjunctive normal form. If CNF is asking, we can write P biconditional Q can be written this formula. Negation P, disjunction Q, outside is conjunction, negation P, disjunction P. In the conjunction base பண்ணி தான் CNF ன்னு சொல்றோம். The value CNF. If P biconditional Q is given like this way. Suppose P biconditional Q. If I want to write DNF, I can use this formula. P conjunction Q, outside is D for disjunction. That is a D disjunction negation, P conjunction negation. So depending upon the problem, you can choose. Biconditional will come. Question is asking DNF using this formula. Question is asking CNF using this formula. P conditional Q meaning this is for conjunction. In between bracket only will come. If you want to change, you can go for De Morgan's law only. We can change the disjunction as conjunction. That is the first step. Try to change it, conditional and biconditional. Second step, if the negation is present before the given formula or a part of the given formula, not a variable, De Morgan's law are applied so that the negation is brought before the variable only. In case of outside the bracket anything, this is correct form. Suppose outside the bracket negation is there, please bring the negation inside by using De Morgan's law. That is the second step. Third step, if necessary, the distributive law and the idempotent law are applied. Sometimes P conjunction P will come, you can write P. Negation P conjunction negation P, you can write P. P disjunction P, you can write P. That is the idempotent law. When you can write distributive P disjunction Q conjunction or P disjunction Q conjunction negation P. Whatever the things, one disjunction, one conjunction, or one conjunction, one disjunction, we can apply for distributive law. Fourth step, if there is an elementary product which is equivalent to the truth value F in the DNF, in case of truth value F or false, DNF of the truth value is false, it is omitted. In a DNF disjunction, you can write false, there is no use because identity law is P disjunction F, answer is P. P conjunction true, answer is P. So CNF, in case of true will come, we can omit the true by using idempotent law. Identity law, using the law is identity. P conjunction true, answer is P. P disjunction false, is answer is P. Other case, P conjunction F is false. That is a dominance law, we can say, dominant law. Okay. For example, I will give some example for example, the DNF of Q tends to P is given by. Step 1, try to change the conditional as disjunction or conjunction. That's why I can use the formula. This is the question is asking DNF. Our P tends to Q can be written as negation P, disjunction Q. Use the formula 2 times. That is the first 2 steps I can write. Then the next step, just I will have to apply the associative and then idempotent law. That's all. The final answer containing disjunction, negation of the terms. That's all. That is a DNF. Suppose the same problem, suppose they are asking say CNF also, the controversy also you can find. The CNF of negation of P disjunction Q biconditional P conjunction Q is given by negation of P disjunction Q biconditional P conjunction Q. Actually, we want to go for CNF. Already I told you CNF meaning you can use this formula. So this formula only I can apply for here, CNF. So first step I can these things. Then I like to apply for go for associative law. Simply count the De Morgan law I can apply inside. After apply the De Morgan's law, I like to go for P conjunction negation P. So try to go for what is the law of negation law. I can apply for negation law and remove the false condition for CNF. This is the final answer. Only 2 terms is there. So try to this formula. You can try in a home itself how to find out the DNF. So that is the main things for DNF and CNF. Okay. So next we move on to for PCNF, PDNF. The same things. Once you know the DNF, CNF, that will be easy for PCNF and PDNF. Yeah, we move on to next one. Before we want to move on to PCNF and PDNF, first, what is the min terms? Elementary sum, elementary product we can study. Now we can come back to min terms and max terms. 2 things we have studied. Min terms, another definition for max terms. Min terms. Let P and Q be 2 statement variables. Construct all possible formula which consist of conjunctions of P or its negation and conjunction of Q or its negation. None of the formula should contain both a variable and its negation. So delete a formula if it is in the commutative of any one of the remaining formula. Such conjunctions of P and Q are called the min terms of P and Q. What is the min terms? That is the meaning of min terms. Suppose you can write the truth table. For example, we can do both the cases. First, I am telling the truth table. For example, you can consider as a two variable P and Q. But there are four input is there. P is true, true, false, false. Q is true, false, true, false. What is the min term? That is the min term is we can write the P is true, then you can write P. Q is true, then we can write Q. P. That is a P and Q statement. Construct the formula as conjunction. P conjunction Q consists of conjunction of P or its negation and conjunction of Q or its negation. So min terms meaning conjunction will come. Max terms meaning disjunction will come. How conjunction? Suppose two input P and Q, only two variables. There are four inputs: true, true, false, false, true, false, true, false. So the output is first line true, true, P conjunction Q. Second term true, false, P conjunction negation Q. If it is false, you can write negation. False conjunction false and true. Negation P conjunction Q. False, false. Negation P conjunction negation Q. This is the min terms. Example, same I told you. Min terms of P and Q are P conjunction Q. That is both input are true. That is the first case now. P conjunction Q meaning both input are true. This is second input is false. That is a true false column. And here first input is false because true, true, false, false. True, false, true, false. That's why I can write 4. Similarly, for three variables, we can get 8 terms. So all the three variables should be present. That is a canonical form. Sometimes they are saying it's a canonical form. All the three P, Q, R. None of the cases missing. Compulsory for three variable meaning P, Q are present, and two variable meaning P and Q are present. In case if any one of the term is not present, you can include the term by using the identity law or idempotent law. You can apply the things. Okay, note each min term has the truth value is true. So the final, for example, if you can do some truth table, you can complete the truth table now. One problem is completed. The final column already you can studied. All the cases, all the values are true, true, true will come. Then it is called as tautology. If all the terms are false, false, false will come, it is called contradiction. Both contingency, both true and false will come. Here, the last column, if it is true, we can write min term. If it is false, we can write max terms. For false case, don't write min terms. For true case, don't write max terms. That is a meaning. If in case the problem is tautology, all are min terms, no max terms. All are min terms only. Min terms meaning conjunction. But the answer is PDNF will come. And a disjunction is outside, PDNF. So PDNF alone will come, that is a tautology. For tautology problem, no PCNF. For contradiction problem, no PDNF. That is the meaning of this one. Similarly, you can go for max terms. For a given number of variables, the max terms consisting of disjunction in which each variable or its negation. Here you can using for disjunction. The same things, true, true. For example, you can here also we can use all the 4 cases as conjunction. For here, all the same 4 we can apply for disjunction. So this is applicable for false statement. The output is false, we can use max terms. The output is true, we can use min terms. So the max terms are the dual of min terms. Sometimes you can convert it into remaining min terms to can find the max terms. That is a duality. Suppose output is 3 true, only 1 false. Suppose 4 input, you can take it as 3 true, 1 false. But 3 min terms is there. 1 max terms will come. So the 4th one also you can write min term. Take the negation, you can got max terms. You can write only min terms. So for false case, you can take the negation, duality, you can get the max terms will come. That's why they are saying the The max terms are the dual of min terms. Each max term has the truth value false for exactly one combination of the truth values of the variable P and Q. The only one variable meaning commutative law should be applicable. So you can apply the idempotent law to, you can write for one term. The next very most important definition of PDNF and PCNF, and also very most important topic in the first unit, the first of, you can expected 1 8 mark comes from, and also sometimes the discrete mathematics they can asking for subdivision, lot of subdivisions, 8 where case 16 for the third unit, sometimes not for first unit. Mostly they can asking 8 plus 8 or sometimes 4 plus 4 plus 4 plus 4, because lot of problems is there. Some statement is given, write the symbolic form, and some PNF, PDNF, PCNF, sometimes omit also PDNF, PCNF, rare cases. So, but important topics for this one, PDNF and PCNF. Principal disjunctive normal form, that is a PDNF. PCNF meaning principal conjunctive normal form. So here the PDNF, principal disjunctive normal form, a formula which is equivalent to a given formula and which consists of sum of its minterms is called principal disjunctive normal form, or sum of product of canonical form. There is a canonical meaning all the variables should be present. That's why I'm saying that disjunctive normal form. PDNF, that is the minterms, sum of minterm. Min meaning conjunction. That's why you can write sum. Max meaning disjunction. That's why you can use product. So principle of conjunctive normal form to equivalent formula consisting of conjunction of max terms only is known as its principal conjunctive normal form or product of sum of canonical forms. Note, to find the PCNF from the PDNF, sometimes I can able to find out the first you should find the PDNF. Sometimes question also is asking to find the PDNF for the following statement and hence find the PCNF, meaning you can use this formula only, you can do it PCNF. Don't try go for step by step PCNF. And hence, the questioning is mentioned, and hence meaning after the PDNF, using the PDF, we can write PCNF. Write negation of the given formula. That is nothing but the disjunction of the remaining minterms. Apply the duality principle. That's all. This is the thing. Like I will give one example for here. For two variables P and Q, so 4 input. So first P meaning 2 true, 2 false. Q meaning true, false, true, false. Negation P, false, false. I can write negation of the given term as I can take it as P. So false, false, true, true. Q tends to P. That is a question is missing, I think, numerator question. I can write, this is the final answer of question. P tends to negation P, conjunction Q tends to P. This is the question. That's why I can try to go for negation P first, this term. Then Q tends to P, I can find next term. What do you mean by tends to conditional statement? True, false alone, false. All other cases are true. True, false meaning Q true. Q, when Q true, P false, he can write false. Q true, P also true. Q true, P false. That's why this place is false. All the other cases are true. Then take the conjunction of these two things. What do you mean by conjunction? One of the input is false, the output is false. Both input is true, then only the answer is true. This is the thing. So but P tends to, same like that. P tends to negation P conjunction, Q tends to P, meaning P here true, false, only false. True, false is false. All the input is false, the output confirmed is true. Okay. I can write min term, max term. What is the truth value of the min term? True. This is the output of the table. Here, where the cases are true will come, you can write the min terms. So it's a true. Where the cases are false, you can write max terms. All are true. That is a tautology case, no max terms. All are false. That is a contradiction case, no min terms. So how we can write this step? How I can write? This is the truth table. I can go back to here. If P is false, that's why I can write false meaning negation, you can put negation P. Min terms, that's why I can write conjunction. And Q, true is Q. Second case. False, false, about negation P, conjunction, negation. Here you can write, apply the disjunction formula. true, true. So Q disjunction Q. True, false. So P disjunction negation Q. So yes, the statement, the given statement problem is yes. So here PDNF, disjunctive mean terms, normal form. These two things you can connect by disjunction formula. Negation of P conjunction negation Q, disjunction negation P conjunction Q. Order whatever you can write. This is first, this is next also possible because commutative law is applicable. This is the PDNF. PCNF, these two things. Then these two things you can write for conjunction statement. Okay, sir, how I can find out without truth table also? Sometimes I can ask him. PDNF, PCNF. They can specify only without using truth table only you can apply. For example, 3 cross 3. 3 inputs are. So obtain the principal disjunctive normal forms and the principal conjunctive normal forms of the following statement using truth table. They can specify it using truth table. P tends to Q conjunction or conjunction. Negation P tends to negation Q conjunction, negation R. So P, Q, R, negation P, negation Q, whatever the statement I need. Question itself, they can take it as this term as A, this term as P. So the entire term is A, the entire term is B. Here the term is C, entire term is D. So P, B, conjunction D. You can take it as 1, 2, 3 also. We don't want willing to write for A, B, C, D. You can write 1, 2, 3 also. Okay. So here I can take it as there are 2 to the power 3, 8 input will come. 4 true, 4 false, true, true, false, false, true, true, false, false, true, false, true, false, true, false, true, false. These are the 3 inputs. This is already well known for the formula for that things, and try to simplify. So what is your final output? You can take it as. What is the final output? We can check. This is the final column. True, all the things are false and last true. Upper we can write PDNF, meaning I want min terms. That is how many true terms? Only 2 true terms. And PDNF and PCNF totally we can only 8. Because 2 of the things are PDNF, remaining 6 as PCNF. So true, true. Remaining 6 terms are false. True, remaining 6 terms are false. Okay, PDNF, the given statement is first and last case, now, true statement. So first for true, here I can go for all the input are true. So I like to write min terms, conjunction we can use. P conjunction, Q conjunction, or all the terms are true. Then outside is PDNF, D for disjunction. That's why I can write disjunction. Next to true cases, all the input are false. That's why I can write negation P, conjunction, negation Q, conjunction, negation. That's all. Remaining 6 terms are for your PCNF. So PDNF of the negation of P conjunction D is, so remaining negation of P conjunction. Otherwise you can write directly. First false, true, true, false, about P disjunction Q, disjunction negation R. And the term, where is the term? Yeah, P, Q, negation R. Then next case. P disjunction negation Q disjunction R. P disjunction negation Q disjunction negation R. Negation P disjunction Q disjunction R. Negation P disjunction Q disjunction negation R. And the last one, negation P disjunction negation Q disjunction R. All other things are connected by conjunction. This is the one of the way we can write directly, or how to use from the PDNF to how you can write the PCNF. This is your PDNF. What is the remaining cases of? Actually totally we have 8 outcomes will come. 2 of them I can write for here. Remaining 6 you can write. That's why you can write negation of the output P conjunction D. If you can take the negation, meaning 6 true, 2 false will come. So on the 6 true order cases I can write for here. Then I can apply the duality principle. Once again, I can take the, so P will come, you can write negation P. Conjunction, change the disjunction. Q, negation Q. Conjunction, disjunction. Negation R, we can write R. Disjunction, conjunction. That is a duality principle. Wherever the term conjunction, you can convert it into disjunction. Wherever the disjunction, we can convert it into conjunction. And negation, we can remove it the steps. In case negation is not there, you can put for negation. That is for your PDNF to PCNF. From this you can able to find out. There is some example for without constructing the truth table, obtain the product of sums canonical form. Product of sum, product upper C, PCNF, product of sums of canonical form for the formula negation P tends to our conjunction Q by conditional P. Hence find the sum of product of canonical form. Sum of product meaning PDNF. So first to find PCNF, from this to find PDNF, or yeah, PCNF to find PDNF from PCNF. This is case. Yeah. Yeah. The first statement. Yes, I think this problem is enough over. This is one of the problem. So yes, this negation P tends to all Q by conditional Q. First I try to change P tends to all meaning negation P disjunction. This formula I can apply, and also B by conditional Q to P conjunction P to all. Then I can apply for double negation law for here. Here also I can apply the same formula next step. Then I can apply for, yeah, clearly disjunction, disjunction, disjunction. Outside is conjunction. So we got it for product of elementary sum, not canonical form. Product of elementary sum, not canonical form. That's why I understood. Product of sum of canonical form, product of sum of elementary terms is there. Only elementary sum. Canonical meaning compulsory three variables, PQR. Three variables compulsory must present. Here the term Q missing. Here the term all missing. Here the term all missing. You can include the term. For disjunction, disjunction will come, you can put disjunction F. For conjunction will come, put conjunction and true. Disjunction, when you can write disjunction, put false. When you can write conjunction, put true. So I can write for disjunction, then conjunction. So negation of this value true. Next step I can go for identity law. Q conjunction negation P. Q conjunction dominant negation law. Q conjunction negation P. Then I can apply for the entire term as P. This is Q negation Q as a distributive law. Just to distributive law, then you can write ascending order. First P, next Q, next by using commutative lemma. First P, PQR, all the term you can convert it into PQR, 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 PQR form. That is easy. In case of that is using commutative law, repetition of commutative law. And any of the cases are repeated, we can omit the term. That is your final answer of PCNF. From the PCNF, write the negation yes. That is a 1, 2, 3, 4, 5 terms are there. Remaining 3 terms I can write. Take the duality, we can get the PCNF. Okay, this is the things is to be there. So up to this you can go to mark. Okay, one more problem is there for one more problem for your understanding for without constructing truth table for find the PDNF PCNF. Okay, so up to this you can go through. Okay, just I can stop presenting. Anybody has a doubt?